In this lesson, we are going to talk about error handling in Node.js. So we're going to talk about error, exceptions, throwing error, bubbling error, and we're going to talk about how to do it in Node.js while focusing on best practices in handling exceptions. So what we will cover today is we're going to do a recap of error class, about try catch, about exceptions. We're going to recap also about sync errors and asynchronous errors. So we're going to talk about also about errors with using promises or EventEmitter or error first callback. We're going to focus on best practices. So there are a few things you can do with your exceptions. You can try and you can catch them. You can let them bubble up. What happens to the node process when you're uncatching an exceptions. So we're going to talk about how to deal with exceptions in the best way, utilizing the best practices we need to use. We're going to talk about let the exception bubble up, because sometimes you cannot deal with the exceptions right away. You need to let it bubble up to the surface or to whatever. If you have a exception in some function, maybe you need to bubble the exception up to whomever called that function. So you need to sometimes bubble up the exception, and we're going to talk about how you do it in sync error and asynchronous error. So I think this is a very important lessons, because the way I see it, a lot of times when I detect errors in when I go to different companies and different Node.js apps, I see a lot of times there are bad practices in handling exceptions. Developers don't test the exception side. Often exceptions are uncaught, or often you have an express app which did not catch an exception, an asynchronous exception, and then it's stuck in a sort of a limbo. So a limbo state where you do not return a response and just wait until the time is over. So there's a lot of bad practices and exceptions, and the best way is just to cover how to deal with exceptions properly. We will start by demonstrating how to throw and catch an error. So we'll do a sort of a recap of how you create an error class that describes your error, how you throw an exception, and how you catch those exceptions, either by try and catch or other means. And we need to demonstrate these recap of exceptions in synchronous errors as well as asynchronous errors. So we need to demonstrate how it works when you write synchronous code and how it works when you write asynchronous code, like promises, EventEmitter, error first callback. So we'll start with the simple one, and we'll demonstrate how to handle exceptions when you write sync code, when you write synchronous code. This is lines of code that is executed right away. So my guess is that these recap you already know, so feel free to skip if you think you know about try catch, about sync errors. But I do recommend at least watching the recap about catching the errors and on a synchronous error. So when you have synchronous code, you use error to describe the error that happens, right? So if I open my editor, I can create a new file. Let's name that file sync exceptions. So we have a class that is called error. So I can create my error is new error. Something happened. And we use this class. This is not an exception. This is a regular class that I'm instantiating. Now, this class is special in a way that it is a class we use to describe an error. So by me creating an instance, I'm not throwing an error. Rather, I'm creating an instance of a class that's supposed to describe an error that is happening. And this error class has human readable message, a code, a stack trace, and you can use this error to throw an exception. So error class is used to describe an error that happened. And you can also you have, other than error is the base class. You have other errors in the system like eval error or stuff like that. So you have classes that extend this base error class to have a more descriptive instance of a specific exception that happened. So you have certain error class that extend it, and you can also extend this class yourself. So if you're creating an app and you want to create your own custom exceptions, you can create your own error class and add methods that you use to describe your your error. But the base class, this is the base class, contains stuff like message code, stack trace, etc. So this is the base class we use to describe an error. Now, this is not throwing an exception, that's describing an error. So if you want to throw an exception, you can use the keyword throw. So if I want to throw, I created a description of my error. I can throw an exception by using the keyword throw and then my error. And in JavaScript, we use the error class and we use throw, and then basically you can use other types, but it is common to use the error class after throw to describe the error. So you place throw and then you throw an exception. So this throws an exception. Now, the error class is also used to describe errors in asynchronous, which we'll talk about later in promises, EventEmitter, error first callback. We use also the error class to describe the error that happens. So the throw is throwing the error, causing an exception. Now, the third keywords I want to talk about exception. You have try, catch. You also have finally. We're not going to talk about finally, but our focus is in the actual exception. So try and catch. You can catch async exceptions, and bear in mind that try and catch is used either for sync exceptions, or the only way you can use it in asynchronous, catching exceptions in asynchronous errors, is by using the async-await, which we'll talk about in a minute. But usually try and catch is used to catch sync errors. So to catch the exception, I can use try and catch. So I'm wrapping a section of my code that can error out, like the throw my error. This section of code can error out, or I don't know, let's say, let's leave the throw here, and let's write try, catch, and the catch gets an error. So let's try and read a file that doesn't exist. Okay, so I'll try to read, let's comment the throw, because otherwise it won't get to these lines, but I can do an import from file system, and we have a read file sync. Okay, because we're talking about synchronous errors still, but I can use read file sync to read a file that's located in here, and the file name is does not exist.txt. Now this will fail. So if you have a section of code that can fail, you can wrap that section of code in a try and catch. Remember, if you have a synchronous section of code other than promise async-await, if you have a synchronous sync, not promise EventEmitter or error first callback. If you have a sync code, you can wrap it in a try and catch. Now, if this method fails, like in this case where we're trying to read a file that does not exist, it will it will throw an exception, and the try and catch is used to catch that exception, meaning my catch will be called, and the read file, the exception will pass the error that happened to our catch. So, for example, we can log out, console log the error message. Okay, so let's try to run our file. I'll place a breakpoint here, and I am going to go to the run and debug using Node.js. So I'm trying to read a file that does not exist, and my catch is jumping with an error that said no such file or directory, and I'm console logging this error message. So basically, these are the main players we're using to describe an error, throw an exception, and catch an exception. So these are the main players we're using on synchronous errors. Now let's talk about asynchronous errors. Those are errors that happens while you're reading a file, waiting for a request, something that you're doing that is asynchronous, sending a query to a database, etc. So let's focus on async errors. How do you throw, catch an exception when dealing with async code? And to demonstrate this, we have to separate to the main players we have in Node for dealing with async code. So we need to demonstrate this catching, using exceptions, throwing errors using the main asynchronous players in Node, which at this time are promise, error first callback, and event emitter. So we need to take these three players and demonstrate how we work with errors and exceptions with promise, error first callback, and event emitter. Probably in the future, embedded inside JavaScript will be observables, which are currently on stage 2. So probably in the future, we'll also have observable, which my guess they will probably a lot of developers will prefer observables than event emitter, for example. But for now, to use observable, we need an external library like RxJS. But at this time, built in Node are these three main players. And we need to demonstrate how to do catching an exception in these three players. If you're interested how error handling is happening on RxJS observables, we have a playlist and a lesson about RxJS library. And there is a lesson there about dealing with errors and exceptions using observables and RxJS. But built in for Node, we have promise, error first callback, and event emitter. And we'll start by demonstrating with promise. How do we deal with errors and exceptions when using some kind of async code that is using promise? Now, promise is heavily used, for example, when you're using a database driver. When you're installing a database driver and want to send a query to your database, usually you'll get back a promise. Now, that query might fail. So how do you deal with errors that happens on promise? So there are a few ways when you can use promise to catch errors and throw errors in promise, and we'll go over the main ones. So one thing you can do is use the promise constructor. So let's go to our IDE and create a new file, and I'll name that file promise exceptions.mjs. And what I'll demonstrate in this file, I'll demonstrate how we handle errors and exceptions in promises. So we have a few things we can do. We can throw an error in the promise constructor. For example, when I'm creating a promise, let's say I'm creating a promise that resolves after 1 second with a message hello to the listeners. So I'll name it my hello promise equals new promise. Now, when you use the promise constructor, you need to pass a function which runs your async code. And after the async code is over, you can call resolve or reject. So I want to promise that after 1 second, it resolves. Set timeout of 1 second, and after 1 second, it will send an hello to the listeners. Okay, great. So this promise will resolve after 1 second. One thing you can do, sometimes your async code, it's not in this example because it's a timer which always succeed, but let's say you have sending something to the database that might fail. So sometimes your async code might fail, and this promise wants to reject, to throw an error. So the way you do it is called the reject. The second method you get in the promise async function, you get a resolve to send the success to the listeners, and you'll get a reject, which you can call to say there was that some exceptions happened. And to do this, you call the reject and you send the reject. You can send pretty much everything, but it's common to describe an exception, an error, using a class of error or one of his child if you're extending it. So I'm sending error that something went wrong. So this is one way to throw an error in a promise by using the promise constructor. Let's go to another way. Another way you can reject a promise is just calling the promise reject. So if I'm going here, I can use promise reject to immediately, sorry if I have type error, immediately send an error. So the way you do it is by calling promise.reject. You don't need to instantiate a new promise. You just call promise.reject, sending here an instance of some sort of error. This is another way to create an error, a promise. This promise will reject right away. So you're sending an error and rejecting a promise. So this is another way to throw an error. Throw an error using promise reject. Let's go back to another method you can use to throw an error. You can use throw. So for example, let's say I have my hello promise. My hello promise, you can connect to my hello promise using then, right? So when you're using promises, one way you can connect to the value inside the promises by using then. Another way, which I find a bit more convenient, is using async-await, which I often use. So my promise dot then, and then in the then you can get like if you're sending a resolve hello listeners, so you get, for example, a message here. So one thing you can do is in the then you can throw an error as well. So remember, the then returns a promise. So if the then returns a promise, but there is an exception in that promise, so it will return a rejected promise. So this is another way, using throw to chain a promise that rejects. So this is another way you can use to reject a promise. Another way you can use is using a throw and catch. So one way you can do in promises, you can catch errors, right? So I can do a then, and I can also you append a catch, which will catch any exceptions. So if I append a catch here, I will get this catch. Oh, sorry, delete these. I can append a then, and I can append a catch. Now, a catch, you can have multiple catches here. Let's say I'm console logging error message. So you can have multiple catch. You can have catch here, and during the promise chaining, you can place catch wherever you feel like there is a promise that might fail. You want to catch a specific error. So this catch will jump when my hello promise rejects, and this catch will jump when the then here will fail. If I would delete this, then this catch will be called if this promise fails or this promise fails. So this way I can kind of catch exception, be specific, create specific handlers for each promise that can fail. So I can create this catch here. Now I can, sometimes there is something specific, some specific error that you want to deal here, but sometimes you have to do if error.code is equals not here. Let's say if we get an error that has a code not here, then what I'm doing is throw error. So what I'm doing here, else I'm dealing with the error. So what I'm doing here, I'm checking the error code, and if the error code is not something that I can deal with in here, I'm just rethrowing it for the next catch. So this is something you can do to also throw an error. Let the error, I want to deal with the error. No, I can't. Throw it to the next error handler. So you can actually use throw inside a catch to throw the error, to bubble the error to the next catch. You can do try and catch and throw in a sync function, which I think it's the most intuitive. So promises allow you, promises allow you to do something of this sort. You can use a sync function, my promise function. Now a sync function always returns a promise. So a sync function will always return a promise. Returns promise. The sync function will always return a promise. During a sync, we can use inside a sync function, we can use the await keyword. So the await keyword, we can place a promise here, and then what we'll get, it's not actually waiting. It's gonna exit the function and continue. A sync function is basically a function with multiple entry points. So it will simply exit the function, carry on with additional tasks, and then when the promise is resolved, you can save the value of hello message. You can save the value inside a variable. So what it will do, it will exit the function and then return when the promise is resolved. Now, when you're inside an async function, you can. This is the only time where you can use the try catch to catch asynchronous errors. So you can use try catch to place promises that can reject, and if my hello promise reject, my catch will be sent. So in a sync function, we're dealing with exception using a try and catch, and we can console log the error message. As well as you can also use in a sync function, you can also use the throw keyword. Something happened. Okay, so basically a sync function, the way you deal with error is very similar to the way you deal with errors in synchronous code using try, catch, and throw. So another one is you can use promise catch to help you catch an error. So this we saw here. Promise catch, you can use promise catch to catch an error. We saw that we can also throw the error in the catch to throw the error to the next catch. So this is a way to pass the ball of the error to the next handler. So that and a second function in then can help you catch errors as well. So the last one is when you're using then, you have also, you can pass in a second function which will be called if the promise is reject. Okay, notice that when you return an error, a reject promise, if you return something and not throwing here, if you like return a new value, then it will be appended to the next then, and you will get the new value that you're sending, the new value here in case of their error. So the promise, it allows you to return something and then the promise is not rejected. If you return something, if you want to throw an exception, reject the promise, then you have to use a throw here. Okay, so remember that basically if you're catching something, then it's not an exception. You're basically returning a good promise unless you're rethrowing the error. So notice that catch allows you to get a failing promise and return a successful promise, and unless you throw something that happened, throw an error, that promise will be successful. So if you want the promise to still fail, you need to throw an additional error. So this is the way we can use promise to throw errors, and use and different ways we can use in promise to catch exceptions that happened. The next asynchronous errors we are going to cover are errors that you need to deal in error first callback. Error first callback is another known pattern in Node.js for dealing with async code, and that pattern sometimes have async errors happen, and you have to know how to deal with errors in your error first callback. So what we'll do is, as usual, we'll learn how to throw, catch an error in an error first callback. And the first thing, if we're using error first callback, then the error is passed as the first argument, as the name suggests. So if we go to our code, let's create a file. Let's call it error first callback exceptions. And error first callback, let's say we're using read file. So read file, let's try and read a file from a path that doesn't exist. So what we have here is when you do a read file, you need to pass the path for the file, and then you're passing an error first callback after this method finished reading the file. And error first callback is the error first callback is sent as the last argument, as you can see here. So with passing the read file the arguments it needs, it might get also, if we go to the read file, we see that read file also get optional options, and then the callback, the error first callback, is always the last argument. So this is the convention, that the error first callback is the last argument, and then you pass the rest of the arguments here. Read file, you can pass the path, optional options for the read file, and the last argument is the error first callback. Now the error first callback is a function that will be called after this file is read or failed to read. And this error first callback, the first argument will be the error. So you'll get here an error. So often we see code like if we have error, then do something. So basically what you're doing here, you're catching the error. It's like the try catch of error first callback. So you do if error, then deal with the error. Console log, deal with the error here. Okay, else do something with the data. Console log, the data is data.toString. Great. So basically what we did here is we used error first callback, and we used the try and catch way to catch the error in the error first callback. Now often you would want to implement, and this way read file already implement the error first callback. You just need to pass the actual callback itself. But often maybe you want to you have something async and you want to implement the error first callback yourself. So let's say we have a timer. Like before, when we created a timer for 1 second, we have a timer and we want to send hello, like we did before, to the listener using error first callback. Error first callback. So this is very similar to what we did previously when we did the promise. It's something we do similar to the previous example when we created a promise that resolves after 1 second and sends hello listeners. We'll do something similar with an error first callback. We create a function, and that function will call say hello. And this function we want to send hello after 1 second. We want to send hello to the listener using error first callback after 1 second. So what we're doing is we're doing a set timeout in this function. So the read file implemented a read file, and then which in our case the async action is a set timeout. In here it's actually reading the file. It's sending to the operating system file, the operating system C++ API for reading files. So it uses an async way to read the file, and then it calls a callback that is passed. So in here we do a simple timer. After 1 second we get in the say hello, we are getting a callback. And this is how you implement error first callback. And in the set timeout, you are calling this callback. And if you have no error, in this example, our set timeout doesn't return an error, but often you want to do something asynchronous that might return an error. So in this case, if we don't have an error, we know that the first argument is the error. So we're passing null, and then we're passing hello listeners. So this is similar to what we did before with the promise in the set promise with the set timeout. And often if you want, like we did before, we did an example of rejecting the error. So rejecting the error is actually calling the callback, but passing new error as the first argument. Something happened. So this is how you pass an error to whomever called your error first callback. You just call the callback, passing a new error. So great. So throwing is pass the error as first argument to callback. This means that if you want to throw an error, you take the callback that you're getting and you're sending an exception. And this is like the throwing part. Catching is dealing with the error argument. So if you want to catch the error like we did here, is simply doing an if we get an error. This is like the try and catch. This is the way we catch the error. If error, then console log deal with the error here. Now, let's talk about sometimes you don't want to deal with the error. Rather, you want to pass the error to upwards, to pass the exception up. So sometimes you cannot deal with the error inside the callback. You need to pass it to whomever called the read file. For example, maybe you have a function that gets my read file, and this function my read files gets an argument of path. And then what you're doing here is you're doing a read file using the path. So you might have this example where you are creating a function, my read file, which gets an argument of a path, and then you use the read file. I got the tabs all mixed up. And then you use the read file inside this function. Now you cannot deal with the error here because, well, sometimes you can. Maybe it's a generic error where you can deal in one place. That's great. But often you want to whomever called the my read file. So if someone called to my read file that does not exist, you want to say to whoever called the my read file, you want him to deal with the error. Maybe you want to tell him this path doesn't exist. So this is not something generic that you can handle here, maybe because everyone's sending a different path. So you want to alert who called the my read file. So the way you do it is you do not deal with the error here like we did before. Instead, you are requesting whoever is calling my read file, you ask him to pass a callback. with, again, error first callback and the data. And what you're basically is doing, instead of dealing with the error, you're getting a callback here, and you're simply calling the callback with your error and data. This is how you let the exception float up. Okay, sometimes you cannot deal with the exception at the point that it happens. You need to whoever called that function to deal with their exception, or even upwards. Sometimes often you use frameworks that have a generic. You use frameworks also give you a door to create some kind of generic exceptions handling. So, for example, if your user is unauthorized, you often want to deal with that exception the same way. So, in Express, for example, you have error middlewares. So you have frameworks that let you deal with exception in a generic way. You just need to pass that exception up. So sometimes you don't want to deal with that exception. You want to pass it upwards. So basically, error first callback allows you to either deal with the error as first argument. If error, then do something. It allows you to, this is how you catch the error, it allows you to throw the error as well. So you can create a function and that throws an error by calling a callback, passing the error argument. And you can let the exception float up by getting a callback and passing the error upwards. So let's show how we throw and catch an error using EventEmitter. Now, EventEmitter is also a widely used pattern for dealing with async code, often with custom events and async code that happens more than once. So, for example, you have the Node process that extends EventEmitter, and you have other elements in Node that extend EventEmitter to create custom events. So we'll show how we use EventEmitter, how we throw an error using EventEmitter, and how we catch that error. And basically, we need to use EventEmitter.emit with a fixed string of error and then pass the error we get. And this is how we throw an error. And to catch an error, we're using EventEmitter on, and then we're placing the string error, and then the callback we want to deal with that error, showing how it looks in our code. So let's create a file called events exceptions.mjs. So I can use import from events. I can use it to import EventEmitter, and then I can create an instance of EventEmitter, for example, my emitter, new EventEmitter. And if I want to declare and to throw an exception, for example, I want to create a set timeout, and after 1 second, I want to send something using my EventEmitter. So after 1 second, I can use the emitter to emit events. For example, I want to emit the event message, and then I can send the message, hello world. Now, when you emit a message, then what my emitter will do, you can add listeners to my emitters. So you can use my emitter, and you can use the keyword on, and when you're getting on message, you can pass a callback, and that callback will get the arguments you are passing after the name of the event. So in here, I'll get a message, and I can console log that message. So basically, after 1 second, I will send to my listeners, I will send hello world, and then after you emit it synchronously right away, it will call all the listeners that are listening to this message. And you can have more than one listener per event, so I can attach more listeners. So for this example, I'm listening to the message event. Let's activate this file using Node, and after 1 second, I see this my listener jumps with the message hello world. Now, if I want to use my EventEmitter, my emitter, to send an error, I can emit an error. This has to be the string error. This is a defined string in Node in the EventEmitter that the name of the event should be error, and then you're passing the instance of your error. It can be a new error or something that extends an error and say something happened. So this is how you send an error using an EventEmitter. Now, to listen to the error, pretty simple, like listening to an event. So you can listen to error, and then you're getting the exception here. And I'm gonna print the exception message. Great. So now we're emitting an exception, sending an error, and then we're catching. This is the throw. The emit error is the throw, and my emitter on error is the catch. Now you can append multiple listeners on the error. So I can do, if I want error to deal with, I can say prepend listener for error. It runs as an array. It runs, so this will run first and then this will run. So I can deal with a certain error. If I get an error with code equals to something, then deal with it here. Deal with it here. And if I'm not dealing with it here, I can do a general error here. So if the error dot code is general error, then deal with it here. Then I can create multiple error, like an error event that catch all the general errors, and error events that catch all the unauthorized user errors, and so on. I can also use prepend listener, prepend once listener. If I want just to try and catch to first run this and then remove this error listener. So I can try and catch in different ways. So the general error will jump for all errors, but I can send something specific once. If I have some code that might fail the event emitter and I want to deal with that failure right away, I can prepend once listener to send the listener to deal with it once. Basically, the way my emitter arranged the error, the event listener is an array. So once you do on, it places the listener in an array. So either you prepend, which push to the beginning of the array, or you place another on, which push to the end of the array. Basically, when you emit, the my emitter goes to the array from the first listener and runs all the listeners in that array. In this way, you can append more listeners to the error event and make your try and catch more complex to deal with certain errors. It's important to understand what happens to the node process when you don't catch an exceptions. So let's check what happens to the node process on uncaught exception. First of all, when you don't catch an exception, the node process will terminate. The node process will terminate with an exit code of 1. And this termination will happen if you don't catch exception with synchronous errors as well as asynchronous errors. So for example, if you have a rejecting promise that you don't catch, your process will terminate. If you have a event emitter that emits an error event and you didn't create an on to catch that error event, then your node process will terminate with exit code 1. The only exception for asynchronous errors is on error first callback. On error first callback, if you don't do something with the error that you're getting as first argument, the node process will not terminate in that case. But if you have synchronous errors, promise rejection that is uncaught, as well as event emitter that emitting an event with no listener for that error event, the node process will terminate on exit code 1. Now, before the node process will exit, remember that the process in node is an event emitter as well. So the process emits certain events. There are certain events in the process that relate to errors that I want to talk about regarding them and best practices, how to use them. So before the process will terminate, the node process will emit 2 events that I want to go over them. One event that it will emit is called uncaught exception handler, and one event that is going to be emitted is an event called uncaught exception. I want to go over those 2 events, as well as I want to emphasize by code what happens to the node process when you don't catch an exception. Going back to our IDE, let's examine what happens when we fail to catch an exception. So for this, we're going to create a new file. We're gonna call it uncaught exceptions.mjs, and we're going to examine what happens. We're gonna experiment here what happens to the node process when we fail to catch an exception. And what we're going to do, usually you often use Node to create some kind of web server, right? So you use Node, you often combine it with some framework using maybe Express.js, maybe Nest.js, and you usually combine Node with some kind of a framework to create a web server. Now, ideally, usually web servers you want to constantly run, right? Those web server needs to constantly get request and return response. If those servers crash, then you're gonna get the request will not get anywhere, and the user will get an error. So usually, when you create a web server, you want the Node process to always run, to always get requests and return responses. So we're going to mimic infinite running web server using set interval. This set interval will run every second. And it will mimic, like, every second we're getting a request. Now, as long as this is running and printing that we are getting new requests, this means that our server is still running and we are responding to our user, which is great. This is what we want. We want, ideally, our web server to always run, always respond to requests. So if I run this file, using run and debug, I should see in the debug console that I'm printing getting a new request every second. This is great. Our server is constantly running. Now let's imagine our server has one route with an exception that we didn't catch. You should always strive to catch all the exceptions that you have, but obviously we will have mistakes, and there are times when we have an exception that we are not dealing with. So let's examine that we have a set timeout that jumps after, let's say, 2 seconds, and this is gonna mimic failing request that triggers an exception which we are not catching. Okay, so after 2 seconds, we get a request to some route. Maybe that request has some weird data in it or something that caused our server to crash, and we didn't do try and catch or whatever means that we have to catch an error. We failed to catch that error. So we can mimic that by, let's say, throwing a new error, something went wrong, and not catching that error, meaning not covering it with a try and catch, just to mimic synchronous errors, an error that's in our code that runs right away. And let's examine what happens. Let's reload our server. Now, if we examine the debug console, we are getting a new request, and then we get a process exit with code 1, something that we said that happens when we have an uncaught exception. Now, notice that my server, the process is gone. The node process is gone. I don't have the debug running. I don't have my server running, and I'm not printing getting a new request, meaning my server crashed. I no longer respond to user requests. Now, the user gets an error. This is why often we don't run our web server using the simple Node. If you go to the Express.js docs, for example, you notice that I think it's in advanced topics. Is it process manager? I think it's process manager. So in here, they recommend to not run your web server simply by typing node and then the file that you're executing, like we did here. We simply run and debug. We'll simply take the uncaught exception MJS and simply run that file using node and attaching the debugger. So here they don't recommend on doing this, and they recommend when you run Express app for production, it's helpful to use process manager. Our process manager is something that we don't use node to run the process, rather using the process manager to run the process, and it can monitor the process, send us feedbacks, logs, restart the process if it crashes. So it restart the app automatically if it crashes, gain insight, modify settings dynamically to improve performance, controls clustering. And they recommend a few technologies here. Personally, I use PM2 often, which is a great tool to run your node process. But in general, what you should take from this is do not run when you run your app in production, do not run it by simply opening the node process yourself using node, rather use some sort of process manager. Now, going back to our code, this error is not only for synchronous error. Let's try throwing different kind of error that we're not catching. Let's, for example, do a promise reject with a new error, meaning I have error in one of my promises. And let's see what happens to our server. Is it still printing? So let's run our file again, run and debug, and after 2 seconds, process exit with code 1. So the same things, our server will crash if we have an uncaught exception for the uncaught promise exception. Now let's examine what happens when you use EventEmitter. So let's import from events the EventEmitter, and let's create, for example, my emitters equals new EventEmitter, and we'll have an EventEmitter that emits an error. With a new error, and we are not doing we're not attaching a listener to catch this error, which is kind of we have an asynchronous exception that we are not catching after 2 seconds. Let's see what happens to the process in this case. Let's run and debug. So after 2 seconds, our processes exit with code 1. The only exceptions that we have here for asynchronous error is when we have, for example, error first callback. So let's say we have import from file system the read file, and let's say we are reading a file that does not exist. So we are reading something that does not exist. Let's say txt, something that does not exist, and then we're passing an error first callback. We will probably have this error field and filled, and we won't have a data, so we can console log the error and not do anything about this error, but our process should still be running. So an error first callback will not crash our process. So if I'm running my code and checking the debug console, even though I have an error, so error first callback does not crash the process. So we saw here that when we're not catching synchronous error as well as asynchronous error of promise and EventEmitter, our process will crash, and our users if our process is crashed and our web server is not running, our user might send a request and get an error and not get responses for those requests. So we saw how Node.js acts when you have sync or async exceptions that are uncaught. Node.js will terminate with an error code of 1. But often when you build a web server, you're using some kind of framework. You're not using Node.js directly, rather you write the web server using some sort of framework, whether it's Express or Nest.js, and then the majority of your code will be written using that framework. So if you're using that framework, most of your code will run on the framework context, meaning the framework might deal differently with uncaught exceptions. And then what happens to your node process might vary depending on how the framework is dealing with uncaught exceptions. And let's demonstrate it with an example and create a simple server using Express.js just to understand how specific framework of Express is dealing with uncaught exceptions. So I'll create a new file, and I'm going to call this file uncaught exceptions in Express and mj.mjs, and in here I'm going to create a simple Express server. So I'll open the terminal, I'll do npm init --yes, and then I'll do npm install Express. Now after I install Express, currently we have in our package JSON, we are installing Express 4.18.2. Notice that Express has a beta of 5, which is in beta. So usually when you npm install, you're not going to install the 5, you're going to use the 4. But pretty soon will have Express 5. And the reason I'm mentioning it, there is a slightly bit difference between how 5 handles errors, uncaught exception, and 4. And we'll touch on it in a bit. So for now, we're on Express version 14.18.2. And let's go back to the file we created, and we'll see in this file, we'll create a simple Express server, and we will notice, and we will try to answer the question how Express is dealing with uncaught exceptions. Is it similar to how Node behaves? So let's examine this by importing the Express application generator function and creating a simple Express application and opening a server that listens on port 3000. And when the server is open and ready to receive request, this callback will run, and then we'll console log, just so we know we are now listening on port 3000. Great. So this is our simple server, and we'll create two get path. One that is we'll call it, the first one is for the path hello, which will simply send us a message hello world. And we will create one path, we'll call it generate error. What this path will do, will create some sort of exception, create exception here, just to see how Express handles it. Okay, so we'll have an uncaught exception in here and see if our server is still running and we're still getting the hello. So let's run our file using the run and debug. Okay, we should see that in the debug console, we are now listening on port 3000. If we go to the hello path, we should see hello world. So let's go back to our browser, open localhost 3000 in the path hello, and we should see our hello world. Great, so our server is running, and now it's time to examine how Express acts when you have uncaught exception. Is it similar to Node.js? Does it behave differently? How Express is dealing with those uncaught exceptions? Okay, so let's examine how Express is dealing with different kind of uncaught exceptions. So we'll start with the easy one. Let's see how Express handles synchronous exceptions. So this is simply to simulate. We'll simply throw a new error. Something went wrong, and this mimics synchronous error, some error that is line by line. It's not something that asynchronous, like query in the database, just bad line in your code. So we'll reload the server, and we'll see what happens if we go to generate error. In this case, we see that Express is not crashing. Rather, Express manages to catch this error, and then Express shows a default error page, where the error page displays the error message along with a stack trace. Now, if the node environment is development, it shows the stack trace like it does now. But if you go to node environment production, like you see here in the process, in the Express docs, you have I think security best practices, where they say use the node environment production. Is it here? I'm not sure. Node and no, not here. Rather, performance best practices. Some best practices, I think. Yeah, set node env to production. So one of the recommendation. In general, not just in Express, if you're using other frameworks as well, you should set the node environment to production when you're deploying your application. So if I'm setting my node environment to production, Express, the default error that Express will present in production is just the error message. It won't display the stack trace, which is a bad practice to display when your app is in production. So Express manages to catch synchronous errors. Now let's see how Express handles if you have asynchronous errors, and we'll start with rejecting promise. So let's try and see what happens if we have an uncaught rejected promise in our Express code. So Express is helping us catch synchronous error. Now let's check asynchronous error in the form of a promise rejection. So let's try, instead of throwing a new error, having a promise reject. Uncaught promise reject. So we have a rejecting promise, but we're not catching this rejecting promise by appending a catch to the end of the promise. So we're not going to do it. Rather, we will let this promise be rejected without being caught. What we saw that in the node process, this will cause the node process to crash. Sorry. Let's see what happens to this rejecting promise when we are in Express context. Does Express catch this promise rejection? So let's launch our server again and go back to our browser and hit the generate error again, now we see that our server is crashed again, and Express doesn't catch the rejecting promise, and it behaves similar to the node process. It simply terminates. This means that if you have in your Express code, you have a promise which you are not catching, it will cause your server to crash. So let's see something similar. We can promise reject like we did here, but something similar that we can do, which is common to do in Express, is make the middleware function here, make it an async function. This way we can deal with promises using the await keyword, right? So we can have, maybe we have a query to the database that returns a promise. We can do await query db and deal with database queries very similar, like it's sync code, but behind the scenes it's like promise. It's like using promises, right? So if we have promise reject here, using the async syntax, will be throwing a new error here. Something went wrong. And it's very similar to a rejecting promise. Basically, when we throw new error, we cause this function to return a rejecting promise. So it's very similar to an uncaught promise like we did before. So we expect the result to be similar like before. And indeed it's similar. If we launch our server again and go back to our browser, we expect our server to crash, and our server is really crashing. So why am I showing you this example if it's pretty much similar to the previous promise reject? Since it's such a common pattern to use async in front of the function, this behavior will change in Express version 5. So this means that an uncaught promise rejection or an async function that throws Express version 5 will help you handle uncaught rejecting promises. And let's try to see how it works. So let's go back to Express documentations and go back and click the home screen, and we'll see here a remark about Express 5 beta, and then here we have a release history of Express. And we have here version 5. So we see Express has a version 5 beta 1. So let's try to install this version. I'm going to copy this, go back to my terminal, and do a npm install Express with this version. This will install the 5.0.0 beta 1. Remember, this is a beta version, so we are going to have to wait till the formal release until we deploy this to production. So let's go back to package JSON just to verify that we have Express version beta now. And let's go back to our code and launch our server again. Run and debug. So our app is running. Let's go back to our browser. Let's go to generate error again. And this time we have the same result as we did with sync errors. So what we have here is Express is catching sync errors like before. Express in version 5 will catch promise rejection that is uncaught, but currently, since this is in beta, it's recommended to work at version 4 before latest version 4 currently. And in latest version 4, our promise and a promise that is rejecting, which is uncaught, will cause Express to terminate, our server to terminate, and the node process to close with an exit code of 1, meaning our server will crash when we have a promise that is rejecting and is uncaught. So in version 5, Express will help you a bit with catching your asynchronous errors, specifically if you have a middleware which returns a promise, which is the case if you have a middleware with an async function inside it. And that promise that you return is actually a rejecting promise. In Express version 5, Express will know how to detect that and will transfer you to the error middlewares. So Express will help you catch rejecting promise, but only on version 5. And we're not yet using version 5 because it's been a while and it's still in beta. So this version is, we're waiting for a long time for this version. And until this version becomes stable, it's not recommended to use Express version 5 yet. So it is recommended to use Express version that is stable now, which is 4. So we'll go back to npm install Express latest and revert back to version 4. Remember, in version 4, Express only helps you catch synchronous errors. Those are errors in your code, not in promises, not in EventEmitter, not in error first callbacks, just regular something synchronous that happens in your code and failing. This Express will be able to catch and transfer you to the error middlewares. We'll have a lesson about Express errors where we will talk further about what is the best practices in dealing with errors in Express, and we'll talk further about error middlewares in Express. But in this lesson, I just want to stay focused on what happens to the node process, what happens to Express when you have uncaught exceptions. So when you're version 4, we actually Express doesn't help you, and you have to catch the promise. Otherwise, you crash the node process, and your server will crash. Luckily, we do not run our server using Node and then just file of our Node server. This is not the recommended way to run your Express server. In case your server is crashing, you don't want your user to stop to crash all your app. You still want your server to come back to life, and even if your server did have an exception and maybe a few requests got lost, you still want your server to bootstrap again and deal with other requests and not crash the entire application. So this is why we're not running our production Node apps using simply Node. So we're following the Express documentation best practices recommendation, and in here you have the section of process managers, and here there's a few recommendations that Express is giving for tools to run your Node app in production. And those tools will make sure that even if your Node process exits due to exception, it will restart again to deal with future requests. So it's not, think about this, it's not that we always have bugs in our code, and your web server will crash. As long as you have good measurement, good logging tools, and you can detect those crashes and deal with them, it's not necessarily the end of the world. To speak, it's a serious bug that we need to handle, but it's kind of a good thing that your Node process crash, in terms that if you log it and monitor it, then you can find those bugs and deal with it and make your app more stable as your app lifecycle goes on. So there is a way where you can avoid to not make your Node process crash if you have an uncaught exception. We'll cover those events soon. It's events on the process event emitter, uncaught exception monitor and uncaught exception. We'll go over them soon. If you implement the logic in those monitor events, then your Node process will not crash, but then you lose the feedback of dealing with the error when your server crashed. So it's not necessarily a good thing to say, hey, my web server never crashed, because there are a few downsides, because you won't. There's a lot of time you will ignore serious bug that way. We'll cover it soon. I want to cover what happens to Express if you have an uncaught error using EventEmitter. So let's try another asynchronous error that we talked about, EventEmitter. So I'll import EventEmitter from events. I'll create a simple event emitter, and I'll have a regular, not an async Express. I remind you that we're back to Express version 4, and I want to see what happens if I take my simple event emitter and I emit an error, and I don't catch that error. So again, we have an asynchronous error that is uncaught, and let's send hello world. Okay, so I'll restart my server and go back to the browser and go to generate error. And now I see that uncaught exception 20, line 27. So Express did actually catch this error and was able to transfer me to an error, proper error page. So in the case of EventEmitter, Express did manage to catch those errors and transfer me to the error middlewares. So we saw that Express is helping us catch event emitters when they emit errors, but is it really the case? Does Express really help us with event emitter? So if Express does something with event emitter to help us, then if I wrap this event emitter with a set timeout, if indeed somehow Express is wrapping those event emitters and helping us, so if I even do this, after 1 second, I take the simple event emit, and then I emit an error. and the response sent hello world. If that's the case, if really Express is helping us with event emitter, then Express won't mind if we wrap the event emitter in something asynchronous, like a set timeout or error first callback or a promise then, if Express is helping us here. So this should lead to the error middleware of Express as well. But if I try to relaunch my app now, and I go back to the browser and I'll go to the generate error, I'll see that after 1 second, my server is crashing and is not running anymore. And I'll see that now I get an exception and an exit code of 1. So is Express really helping us with event emitter? The short answer is no. And so why did the previous example, why did Express actually help us when we didn't wrap our event emitter in a set timeout or in an asynchronous callback? So if I placed this outside the set timeout, I saw that Express helped us in that case. And the reason is when you take the event emitter and you emit an event, at the point of that you start emitting, synchronous code is running. So what event emitter is doing synchronously is going to the array of listener that is subscribing to that event and start calling each one in a synchronous manner. So basically, when you emit an event, synchronous stuff happens. The thing is that you usually emit the event when something asynchronous happened before. So this is not really a good example that represents the real life, because probably you will use the event emitter in some kind of a sync block, right? So usually you use event emitter for asynchronous stuff. So this line of code, although in this case, because it's the emit is actually sync in nature, Express will help you catch this kind of error, but usually that won't be the case. You won't simply place an event emitter and emit an error. Usually, probably the real case would be it will be wrapped in some kind of a synchronous code, and then you'll emit the event. And in that case, Express doesn't really do anything with event emitter or with that class, or does some changes to inspect those error. So Express most likely won't help you with event emitter, only in the rare case where you just plain simple emitting an error event inside without wrapping it inside the route middleware, without wrapping it in some sort of a sync code like we did with the set timeout here. So Express doesn't really help us with rejecting promise, at least in version 4, with uncaptured rejecting promise. And Express does not really help us with event emitter that is emitting errors in some kind of asynchronous block. Let's check the third option for asynchronous, popular asynchronous way to deal with asynchronous code, which is the error first callback. So let's place a remark around the event emitter, and let's try to read file using the read file which is error first callback. You also have read file that returns a promise. So read file, we're going to read a non-existing file, and we are going to place an error first callback, and the error first callback gets the error as first and the data of the file as second. Now the read file is imported from the Node file system. You can also have read file that returns promises from file system -promises. So, but we'll keep it as a error first callback. We already checked the promises. So let's read file, non-existing file. This should return an error. Now nobody will help you with error first callback. The node process will not crash on error first callback like the node process is crashing on uncaught promise rejection and uncaught event emitter emitting an event. The node process will crash in those events, but on error first callback, the node process will not crash, at least unless you maybe throw that error, then it will crash. But by default, the node process will not crash if you have an error as the first argument. So if you have an error in the first argument, Express, like the node process, Express won't help you as well. So what usually you have to do is you have to manually pass the error to the middleware next function. So you grab the middleware next function, which is the third argument, and then if you have error, you call the next and you pass the error the error instance that you get as the first argument. Now, when Express sees that you're calling next with an error class instance, then Express will transfer you to the error middlewares. So when error first callback, you have to call next and pass down the error. And let's say if we don't have an error, then we'll simply send, let's say we're sending hello world. So in this case, if we launch our app, and we'll go to the generate error path. So let's open the browser and go to the generate error path. We should see that our server is not crashed, rather we are transferred to the error middlewares. So we see that our server did not crash, and if we go back to hello, our server is still running and will print hello world. So going back to hello, we'll print hello world again. Great. So error first callback, nobody helps you. You have to call the next and pass down the error that you're getting as first argument. So Express doesn't really help you catch those asynchronous errors. So you will have to do it yourself. And sometimes we forget or we make mistakes and we don't catch those asynchronous errors. And what will happen by default is most likely they will cause your node process to crash. So the thing is, we have to protect ourselves somehow while doing best practices and transferring the user. Even if we didn't catch those async exceptions, we would want some fallback that will catch those exceptions for us and will transfer the request to the Express error middleware. So obviously the most recommended way is to catch it yourself, but we will have mistakes, and in this case we would like a fallback to catch those exceptions that we miss for us and transfer the user to the error middleware. So here in Academeez we develop an open source MIT licensed middleware to help you catch automatically those async exceptions that you forgot to catch yourself and then transfer to the error middleware of Express. So let's go back to the browser and check it out. Like everything we develop in Academeez, obviously it's open source and MIT license. So you can go to github.com, my user, YWAREZK, and then the middleware is called Express Errors. And this, of course, if you like this middleware, if you want us to keep developing it to newer version and improve it, show us your love by starring this middleware. If we see a lot of support by starring, we will continue and develop further versions. So what this middleware is basically doing is wrapping the request that is entering in an execution context. So Zone.js is a library developed by Google that adds execution context. So execution context is like placing your code inside a building, and then when a request is entered, I'm placing that request inside of a room in that building, and that room has certain alarms. For example, you have an alarm for when the code in the room has exception, and then I wrap it in execution context and I can tell when I have an exception in my code and then transfer the user to the error middleware. So this is the execution context, by the way. Zone.js developed by Google, but currently it's in it has an ECMAScript proposal, so it's going to be probably in the future will be part of JavaScript, probably in the far future, because I think it's in stage 1, if I'm not mistaken, the Zone.js proposal, but it will be in JavaScript in the future. For now, until it is, we have to use it as a library, as a Zone.js library. So let's install this library, npm install az express errors -- save. So let's install this package. So the best way this package works better if your project is either TypeScript project or you have some kind of compiler like Babel that transpiles your code. If you just write plain JavaScript, there will be some things in this middleware that does not work, and I'll explain why during our development. But so to test this middleware, let's start a new project and let's start a TypeScript project, and let's see how this middleware helps us catching those asynchronous errors. While we have promise rejection and event emitter and maybe error first callback, let's see how this middleware helps us catch it by starting a new TypeScript project and installing that middleware. I'm only doing that because this middleware works best with TypeScript or with JavaScript compiled with a transpiler like Babel. If you don't have those, that middleware will still work, but in some cases, where I will show it won't work as it won't work in some of the cases, and I will emphasize it while we demonstrate this middleware. So let's start a new TypeScript project to demonstrate Academeez Error middleware. Great, so let's test this cool middleware by Academeez, and we'll create a new TypeScript project. So I'm gonna npm install -d TypeScript. And the easiest way to create, and when we install a TypeScript, we want to create a tsconfig file to configure the TypeScript compiler. Now, the easiest way to create a tsconfig file is just using the TypeScript compiler tsc using ---- init. This will create a tsconfig file, and we'll keep this tsconfig file. Let's open the tsconfig file. We'll keep the tsconfig file as is, except one change. We'll search for source map, and we'll uncomment it to place source map true. This will create a source map, and then we can run things using our VS Code debugger. Great. So now let's create a new TypeScript file. We'll call this file Academeez AZ error middleware. Great. And let's run our TypeScript compiler to automatically compile every time this file is changing. So I'll open the terminal and I'll do npx tsc TypeScript compiler -w, watch for changes and recompile. Great. So now let's import, and what we'll do in this file is examine which async exceptions does the Academeez error middleware. Let's close this, the Academeez error middleware catch. And we'll create a new Express application. And for TypeScript to know exactly the Express declaration, it's best to install the Express types. So I'll open terminal, and I'll open another terminal, and I'll install npm install -d types express. Great. Now let's create a new Express application, and then let's listen on port 3000. And now let's have an app.get for let's say and let's response in this route. Let's response.send hello world. Let's just verify that our project is working. So I'm going to place a breakpoint here and then do a run and debug using Node.js. Our server is running. Let's open the browser and go to localhost 3000 and see that we have hello world. Great, our breakpoint has stopped, and then if we continue, we should see hello world on the screen. Great, we started our TypeScript project. Now let's install the Academeez error middleware, and let's examine which exception does this middleware help us catch. Our server is running. Now let's check which async exception does this middleware helps us catch. And to install this middleware, remember you didn't do npm install it. npm install az express errors latest. We already did that. So after this middleware is installed, it's just you connect it to Express with like regular middlewares. So I'm gonna import a middleware creator function. Let's call it az errors from the middleware package, AZ Express Errors, and to install it, you simply do an app use and call this middleware creator function, AZ Errors, and now this middleware is installed. Now, let's comment this and not install this middleware for a second. And let's see what happens. We saw that if we have a rejecting promise, so for example, promise reject with a new error, this will cause the node process to crash with an exit code of 1. So let's start our app, and we'll see that if we go now, our promise rejection is running, and this should cause our server to crash. Now let's see what happens if you use this middleware. So I'll uncomment this and run and debug again. Now after I run my code, the server is not crashing. In fact, it catches the promise rejection that we didn't caught, and it will transfer the request to Express error middleware, where the default error middleware will print the error along with the stack trace. If the node environment is in production, it will not print the stack trace, only the error message. Great, so it helps us with promise reject. Let's check what happens if I have a promise rejection using async-await. So I'll async this middleware function, and I'll throw a new error with some error, and then I'll relaunch my code, and let's see what happens now. I have another, let's to distinguish this from the other exception, let's say some error 2, and let's reload our app. And now I have, again, my server is not crashing. This would cause my server to crash if I didn't have the Academeez Error middleware. My server would crash. Now it manages to catch this exception and transfer me to Express Error middleware. So my server is still running. Great. So it helps us with promise rejection. Let's see what happens with EventEmitter. We saw that if I have an EventEmitter which emits an error and I don't place a listener to catch this error event, this will cause my node process to crash with an exit code of 1. So let's try this again. Let's import from events the EventEmitter class, and let's create a new, let's say my error emitter. And what I will do is in my code, I will create a set timeout, and after 1 second, I will call the my error emitter. I'll emit an error event. Something went wrong in my event emitter. Now this caused the node process to crash in the previous example. Let's see what happens if we install the Academeez Error middleware, and let's restart our server. Okay, so after 1 second, we should be transferred to the error middleware. Our server is still running. If you didn't have the AZ exception middleware, again, my server would crash after 1 second. So let's do again without the Academeez Error middleware. My server is now crashed. So it does help us with promise rejection. It does help us with EventEmitter. Now, the reason I wanted to do it in a TypeScript project, if you are not in a TypeScript project or you are not in a transpiled Babel project, then if you place use async-await, then Academeez Error middleware will not help you if you're not in TypeScript or Babel. It will not help you with async and with a throw new error in the async exception like we did before. So it will not this async middleware will not work with the Academeez Error middleware with vanilla JavaScript. Okay, so only with vanilla JavaScript. If your code is transpiled with Babel or TypeScript, then the middleware will work. And it's not that the middleware will damage you in some way if you're not using Babel or TypeScript. It will simply not be able to catch the async if you throw new error. The reason is when JavaScript is using async, if you're not transpiling this code, it uses native promises and it doesn't use the Zone.js wrapped promises. This is the reason why it's not working. It's an open issue in Zone.js, but it will work if you use TypeScript or Babel to transpile your code. Great. With error first callback, this middleware won't help you that much. What you can do, let's import the read file again. I'll take it from the previous example. We have an error first callback that is failing, a read file for a non-existing file. This is failing basically. And what we said we should do is we should pass the error just simply to next. Using context awareness, I can take the request and I can run a code in the request. After you install the Academeez Error middleware, you have appended to the request, you have the execution context, AZ zone. And then you can run run guarded your code. This will run even if read file is not wrapped by Zone.js. You can run a function using your execution context, but I should probably wrap the request. And now I can simply, if I have an error, I can do a throw error. Just use throw. If you're in the execution context, you can use regular throw, even if you're in an error first callback. So it doesn't wrap read file, but you can run every error first callback using the run guarded, and then you can simply throw that error. So it does help you in some way, but Zone.js doesn't wrap this read file, so it doesn't help you. You cannot simply run the code and throw the error, but you can take the execution context from the request. The Academeez Error middleware is placing in the request the execution context. Let's see that it's working. So it should fail to read the file, but it should not crash the server. It just transfers us to the error middleware. So you can now use throw inside error first callback, which is a much easier way to deal with the error in your error first callback function. So just to summarize this example, we saw that Express doesn't help you with asynchronous errors like promise rejection, event emitter, and error first callback. In Academeez, we developed a middleware that helps you deal with those async exception. So in case you make a mistake and do not catch those async exception, we got you covered. You have Academeez Express errors middleware, you install it, and then it will help you catch the promise rejection errors that you didn't catch, the event emitter errors, the error first callback. It exposes the execution context, and you can run things inside the execution context and then use throw whenever you want to pass to the error middleware. So it's a really easy way to deal with exceptions, especially asynchronous exceptions, and it protects you against the mistakes you will make when you don't catch those asynchronous exceptions. So check out Academeez Express errors. Show us your love by starring this package. Also, by starting the package. Also, if you find any issues, please report these issues. If we see the love, we'll continue to develop this this Express middleware. We'll continue to develop it further. Let's talk about the process events, and the process events that relates to exceptions that are uncaught. So for this, I'm gonna open a new JavaScript file. We'll go back to JavaScript, and we'll talk about process error events. And I'll go back to JavaScript, and in here I'm going to use when you start a node process, when you run your node script, you have a global. Your process class instance is exposed to you globally. So you can just use process and, for example, process end or process on. And if you control click or command click the process, you'll see that what you're getting is you're getting it in the global, and you get a Node.js process, which the Node.js process extends event emitter. So basically, the process that you're getting is something that extends the event emitter. This means that the process emits event, and you can subscribe to those events in the same way that you subscribe to events in event emitter. So let's go back. So the process has to subscribe to those events. You can say process on, and in here you place the name of the event, and you have a few events that you can subscribe to, and then you attach a listener, some event, and then you attach a listener with passing a function by. Better on passing a function like this and not an error function, so we can access this if we need. Okay, so we get the process exposed to us globally, and we can subscribe to events. Which events we can subscribe, we need to read in the docs. So let's go back to our browser. Let's go back to Express documentation. Let's go to API reference version 4, which we are not working with the beta, and version 4, where is that? Oh, sorry, it's not Express, obviously, it's Node.js. So I'm confusing the docs. So let's go back to Node.js docs, because the process is part of Node, not part of Express, right? So let's go back to Node.js, and let's get the latest version and read about the process. In here, you have a process, and this describes the API that you get in the process, including the events that you get. So you have certain events, and usually those events are used for a certain purpose. So for example, you have a few events that relates to exceptions that are uncaught. So if you look here, you'll see you have event for uncaught exception. For example, if you have an exception that propagates without catching, for example, if you have a promise reject and you didn't catch it, this event will be called. In fact, this event can also be, you can use it to prevent the node process from crashing. We'll talk a bit about it later. You have also an event that relates to uncaught exception that is called uncaught exception monitor. So let's check out these events and check out when those events are used. So we want to examine the events on the process that are triggered when you have unhandled exception that you're not catching. So to do this, we will do like mimic. When we create a web server using Node.js, usually that web server is always running. So we'll create an always running server using a set interval. So let's say we have a set interval that runs every second and prints to the console, I'm running. Great. And now let's mimic a request that is entering after, let's say, 2 seconds. A request is entering, the web server is processing that request, but some kind of unhandled exception is happening in that request. So let's do a set timeout that is triggered after 2 seconds. And this timeout have a throw new error, which we are not catching. Something happened. Great. So right now, if I trigger my this demo server, if I trigger it, if I run and debug it, so I get in the debug console, I get these logs. My server is running, but after 2 seconds, I'm exiting with an exit code of 1 because I have an unhandled exception. Now I can try to see my process and examine those events that are triggered when you have uncaught exception. And the first event we will examine will check out the uncaught exception monitor event. So this event, let's see, let's read in the doc. The first argument we're getting is the error that was uncaught, and the second argument is the origin, indicates if the exception originates from an unhandled rejection or from synchronous errors. So basically, it's a string that says what is the origin of the exception. Is it something sync or something async? And the uncaught exception monitor event is emitted before uncaught exception. So we'll go over uncaught exception monitor and then uncaught exception. Event is emitted or hook installed via process set uncaught exception is called. Installing an uncaught exception monitor listener does not change the behavior once an uncaught exception event is emitted. The process will start crash if no uncaught exception listener is installed. So this event doesn't prevent your node process from crashing. It is simply used to do some kind of log of the error, maybe create a log file to specify that exception that happened. Basically, it's used for monitoring, and it will not prevent your node process from crashing. So going back, I'll go to the process on, I'll do an uncaught exception monitor, and I'll get here the error, and I'll print out this will be called before uncaught exception event. This is number 1. It won't prevent the node process from crashing. And we use this event to log the error or create a log file with the error, or stuff that relates to logging that error. Great. I'll get here the error, so I'll get the something happened here. I can print also the console log error message. And let's check what happens now if I relaunch my server. So I'll check out the debug console, and now we see that something happened. It will be called before uncaught exception. It won't prevent the node process from crashing, and we use this event to log the error. So this is the error message, and we see that this event is called, and we can use it to log the errors that we didn't catch. Great. So this is the first event that I want to go over. Now let's go to another event, process on, an uncaught exception. And let's check, uncaught exception. Great, let's check what the docs are saying about this event. So let's go back to the docs and go to, where is it? Uncaught exception. Let's go back to the top and uncaught exception event. Okay, so great. So this event also gets the error that is uncaught as the first argument. Origin, same as before. What's the origin of the exception? The uncaught exception event is emitted when an uncaught exception bubbles all the way back to the event loop. By default, Node.js handles such exception by printing the stack trace to std error and exiting with code 1. Overriding in previously set process exit code, adding a handler for the uncaught exception event overrides this default behavior. Okay, notice that this important line, exiting with code 1. Overriding any previously set process exit code, adding a handler for the uncaught exception events override this default behavior. What does this mean? If I go and I create this event, let's place a log here, and let's place the uncaught exception monitor in a comment so we can see the logs more clear with less logs in the console. So now what happens if I run my code? So I see that I'm keep on running. So if I add an event to this to the uncaught exception, we saw that before this event, when we did a set timeout, is it caused the node process to exit with an exit code of 1. If you implement this event, then what happens, it prevents the default behavior of the node process, and the node process will not crash when you have uncaught exception. That is interesting, and it might be tempting to use this event to prevent my node process from crashing an uncaught exception, but in fact this event is not used for that and is not recommended to use this event to prevent the node process from crashing. In fact, what is more recommended to do in this event is a cleanup before you exit. Maybe delete files, maybe exit in, you're going to exit the process, so clean up stuff, closing some subscription, file subscription, some sockets, do general cleanup before you exit. And then you exit. You might also change the exit code to something more clear if you want, but basically you do not use this event to prevent the node process from crashing. Rather, you use it to clean up before you crash. And the reason you don't prevent your node process from crashing, it's like a catch-all, try and catch. When we'll talk about best practices regarding exceptions, one of the things that we'll say is do not do a catch-all, try-catch kind of thing, which will catch all your errors. You need to be specific, otherwise it will be impossible to get to know what the exception that caused your crash. So it is okay to make the node process crash if you have unhandled exception. I would add in the process manager some kind of logging mechanism in case you have exception to report that by the process manager, not by this. By the process manager like PM2, you can detect when your process is crashing and then report to your logging server or whatnot. But I won't do a catch-all exceptions like this because it prevent me, it will look kind of tempting, but it will prevent me to know what my error is in the future and defend myself against those exceptions that I didn't catch and I need to catch. And in fact, the same thing you can read also in the docs. Bubbles all the way. By default, Node.js handles such exception by printing the step. Adding a handle to the uncaught exception event overrides the default behavior. We were here. Alternatively, change the process exit code in the uncaught exception handler, which will result in the process exiting with the provided exit code. So one of the things you can do is you can do a process exit. You can check if my error is something, error code is equals to something, then I want to process.exit with an exit code of 100. I don't know, depending on your what you define as the consistent exit code in your app. So with provided, otherwise in the presence of such handle, the process will exit with 0. Okay, so one thing that I want to note, warning, using uncaught exception correctly. Uncaught exception is a crude mechanism for exception handling. Okay, it's not, the purpose of this is not exception handling. Intended to be used only as last resort. The event should not be used as an equivalent to on error resume next. Okay, it's not like, okay, I'll prevent my node process from crashing on uncaught exception and then I'll proceed on to process request like nothing happened. Unhandled exceptions inherently mean that an application is in an undefined state. Okay, sometimes you have exception, you don't catch them, and it's actually very serious, and your application might be in an unstable state, which might deteriorate even further. Attempting to resume application code without properly recovering from an exception can cause additional unforeseen and unpredictable issues. Exception thrown from within the event handler will not be caught. Instead, the process will exit with a non-zero exit code and the stack trace will be printed. This is to avoid infinite recursion. Attempting to resume normally after an uncaught exception. Okay, this is important. I like this analogy. Attempting to resume normally after an uncaught exception can be similar to pulling out the power cord when upgrading computer. 9 of 10 times nothing happens, but the 10th time the system becomes corrupted. Okay, so you don't catch uncaught exception and deal in this event. It's like pulling out the cord from your computer when your computer is upgrading. You don't know if your server is now in an unstable state, which might deteriorate, which might be exploited by hackers. The correct use of uncaught exception is to perform synchronous cleanup of allocated resources. Like we mentioned, clean up file, delete files, file descriptor handler before shutting down the process. It is not safe to resume normal operation after uncaught exception. to restart crashed application in a more reliable way, whether uncaught exception is emitted or not, an external monitor should be employed. So usually, as we said in the Express docs, they mention that you should run your Node apps using process managers, like PM2, for example. And those process manager have can tell you when your process is crashing, and then you can use it to monitor and log. So you use this event and do not abuse the uncaught exception event. Should be employed in separate process to detect application failures and recover or restart as needed. So it's very important to note, because I did notice few organizations that implement this to prevent their app from crashing. This is not the reason why this event exists. This event exists to, okay, I got an error. I want to exit code with a specific exit code, not exit code 1. Okay, I want to clean up things before I shut down. These are the things that this event is used. This is not used to say, okay, I'm going to catch all my uncaught exception in one place and then deal with them in one place and do not prevent my node process from crashing. So we checked out a few of the error exception events of the node process. Now let's summarize what we covered so far. What happens when we're in our express route middleware and we're not catching an exception? So synchronous errors, like you're trying to access a property in an object or something sync in your code that you're not transferring, Express will transfer it for you to the error middleware. So no worries there. Express got you covered on sync errors. When you have asynchronous errors, for example, a promise rejection, which you are not catching, on Express version 4, nothing happens and your process will crash. Express will not help you with uncaught promise rejection. On Express version 5, which is still in beta and not recommended for using yet at this time of when this video is out, on Express version 5, if you have a route middleware which returns a promise, if the promise is rejected, Express will lead you to the error middleware. So on promise rejection, Express version 5 will lead you to got you covered and will lead you to the error middleware. On EventEmitter, on 99% of the cases, the event emitter is usually in some sort of async code. Express will not help you catch that, and the process will crash. If you're not implementing the event on error, your process will crash. So an error first callback, nothing will help you, not Express, not your node process. You'll have to catch the error and transfer it yourself to the error middleware. So if Express is not helping you with the errors, then what happens, those errors is going to the node process. Now what happens to the node process when you have uncaught exception? The node process will terminate with an exit code of 1, except error first callback. So it returns an exit code of 1 and will run a few process events before exiting. And if you implement the uncaught exception, then the node process will not necessarily exit. So if you implement uncaught exception, you can prevent the node process from crashing. But usually it's not done. Maybe you do it for cleanup, maybe you do it for returning exit code other than exit code 1, but usually don't abuse that event for a global try catch that prevents you from your node process from crashing and catching all your exception that is uncaught. Usually what happens if you do that, naturally you will ignore serious exceptions, and might be that you keep your server running while your system is corrupted. So bear that in mind. You have uncaught exception monitor to monitor your exceptions, maybe log them, and you have uncaught exception, which mainly used for cleanup, returning exit code other than exit code 1, and do stuff you want to do before the node process is crashing. Now, I want to go over best practices dealing with exception in your Node.js application. But before I touch about best practices, we need to understand what happens to your uncaught exception. And then we need to understand what I call the exception journey. What happens to your unhandled exception? And then we need to understand what can we do with exception. We have a few mental notes that we need to understand what we can do with our exception, and then we can talk about best practices. So starting with the exception journey. So when the node process is running code, it runs a code in a stack type called the stack trace. At the top of the stack is the current line that the V8 of node is currently running, and below, in our example, the stack trace contains A, like line of code that we marked as A. This is a code with exception, and and the stack trace one level down, you have a function that called the A code. So one level down, you have code B, which is the parent A function, the function that called the A code. And one level down, you have code C, that is the parent B function, the function that called the B code. So this is like a stack type where you're currently running, and a level below is a function that called what you're currently running, and then so on and so forth. So what happens when you have exception in your code? Let's say we have a code A with exception. So what happens now depends what you're doing with that exception. If you're not catching that exception, if that exception was not caught, what is happening is the exception is moved a level down. This means that whoever is called parent A, that exception now happens on the code B that called the code A. And in here, you can place maybe there is a try and catch or something to catch the error. But if your exception was not caught, then it moves to the parent that called code B. And in code C, maybe they have a try and catch, and maybe they tried to catch errors. But if they didn't, it goes downward and downward and downward to whoever called the function, and down to the root level. This is the process. And if you're not catching the exception there, what happens is your node process is crashing. So basically what happens to your exception, it goes to the line of exception, then move down to the parent. If the line of exception did not catch, then it moves to the parent. If the parent did not catch, it moves to the parent of the parent, to the grandfather, I guess. And if that didn't catch, it goes downward and downward and downward. If no one caught the error, then what happens is the node process will crash. I think it's something that is clear, that we learn at the very early age when dealing with exception in pretty much every programming language, right? You can either catch the exception, or it moves to the parent and downwards until, if no one catches the exception, your node process will crash. After covering the exception journey, let's see what you can do with the exception. If you have exception with your code, how you can deal with that exception. So obviously, we need to strive to catch all exceptions that happens in our node application. Otherwise, our node application might crash. So we need, when we write a piece of code that might fail, basically we can do the following. One, we can wrap the code in a try and catch. We can catch that exception that's happening at the point where that exception happened. If you have some line of code that might throw an exception, I'm going to wrap that line of code with a try and catch. Catch the exception when it happens, and deal with that exception when it happens. You cannot always do that. Sometimes you have to let the parent handle the exception. And in that case, you have to let the exception bubble up to the parent. In case you cannot handle with the exception, you can let the exception float up, and one of the parents that ran the code might handle that exception for you. So one other thing that you can do with exception is let the exception bubble up. Your third option might be a little bit of combination of 1 and 2. That is to catch the exception and then rethrow it. This is good in the case when you have some sort of generic error and you're catching an exception and you're throwing your generic error, and let the parents handle the generic errors. We'll talk about best practices based on those 3 ways of you to deal with exception. And let's talk about those ways in a more graphical way. So the first option you had is you can catch the error. This means when you have a line of code that might have an exception, you wrap it in a try and catch, so you catch that error, and then you're good to go. You're dealing with that error. If I demonstrate with a line of code, so let's open a new file. Let's call it dealing with exceptions .js, and let's say you have, I'm not going to write the entire code, so this code is not runnable, so it's just pseudocode. So let's say you have an Express application, you are implementing let's say const let's say declare var app as, oh sorry, it's not TypeScript, so let's do it as a TypeScript so it will be more clear. I'll do it as a TS file, and I'll do declare var app as a TypeScript as an express application. So let's say in the first way, when you catch the exception, you might have an express route, let's say for the root, and then you have the request response. You have some kind of code that might have an exception. This code might have an exception. Let's say this code is console log. I can have an exception here. And then you take that code and you deal with the exception at the point of the exception, meaning you wrap it in a try and catch if it's sync code or it's in a sync function. If it's something async, you need to deal with it the way you deal with exception on EventEmitter or error for callback. Every method you have to deal with sync has its own way to deal with error. So the try and catch doesn't always it's not always with try and catch, but I think it gets the point on. So you should catch however the async way, the method to catch an error. So if you have a problematic error, I'm dealing with the error here in the catch. Deal with the error when it happens. So this is the first way where you handle the exception at the root point when the exception happens. So this is the first way. So this is when you have an exception in A and you wrap it in a try and catch. The second way is you let the exception bubble up. So let it bubble up, do not deal with the exception. In this case, you have some sort of exception in code A, but you're not dealing with the exception. Rather, you let one of the parents deal with the exception. So you're not wrapping it in a try and catch, and you just let the parent handle it. So in our case, the parent B catch the error. Of course, it doesn't have to be the exact parent above. It could be that parent C maybe caught the error. You just let the error bubble up, and maybe B also lets the error bubble up, and maybe C is the one that handles with the error. But basically, we have an error, and we'll let one of the parents handle the error. So in this case, in this diagram, parent B caught the error, and then you're good to go. So in our case, if you want to let the parent handle the error, so it looks something like this. In Express, let's say let the parent handle the error. So in our case, let's say we have a function. Let's say you have a function that is query the DB. And this is an async function that gets a query, which is a string, and then it returns like a promise with the result from the database. Let's say the result is any. So query the database, you get this function gets a query and then runs the query. So let's say the code here runs the query in the database. Obviously, the query can have exception. So let's say you have an express route, and our express route is calling query the DB, and await query DB. Let's say if it might fail, if there is an error, we'll throw an exception. So I'm calling query the DB. Why is this? There is exception here. An argument for queries was not provided. I'm giving it some illegal query. Sorry for misspelling illegal, but you get the point, I think. So in this case, we are not dealing with the exception in the query DB, right? So you are running the query in this function, but I'm not going to deal with the exception in this function because this function is too generic. It might be called in different routes, so I might display a different error in different routes. So in this case, I'm dealing with the exception not in the function, not in the origin of the exception, rather in the parent that called the exception. In here, I'm going to wrap it in a try and catch. Try and catch, and deal with the exception here. Maybe send a response, send some error message. So you cannot always deal with the exception in the origin of the exception. Maybe you need to deal with the exception in one of the parents. So this is number 2. So number 3 is catch and throw. In this case, if you have something generic that handles your error, you might catch the error and then throw a generic error. So let's say you have a code with exception in line A, you catch that error and then you rethrow that error and let one of the parents handle the error, the error, maybe a different error that you changed a bit. So one of your generic error functions can handle the error. So it's like a mix of 1 and 2. You're catching the error and then you're throwing it again or throwing a different error. Let's see an example in Express. So let's say I have 3 combine catching and rethrowing the error. In Express, it might be that I have some kind of class. Let's say extending query error that extends error. I'm creating some kind of my own error class, and then I'm doing something like this. I'm doing copy paste. I'm catching the error, and then I might, instead of catching and doing nothing, I will just create, let's say, a query error, and then pass it along to the error middleware. So this is the equivalent of number 3. I have something generic, some generic error middleware in Express where it handles all my database query errors. And then I can catch the query DB, and then I can pass it along to Express to the parents to handle that generic exception. So I have some sort of exception which is not generically handled. I'm catching it and then passing along to one of the parents, but I'm passing a different exception of the type of the generic exception that I do have implementation for. So in that case, I can enjoy catching the error and also enjoy my generic error middlewares. So in that case, I am catching the error in A, but I'm throwing a different error because I have some kind of generic implementation in Express error middleware. So this is the catch and throw, a combination of 1 and 2. So you have 3 ways of dealing with exception. 1, catch them at the root, where obviously you would prefer number 1. If possible, just catch and deal with the error at the point of origin. With some maybe it's not always the obvious, because sometimes we'll talk about best practices. You have some kind of generic error, so you might pass along to the generic error middleware. But number 1 is catch the error at the root when it happens. Number 2, let the exception bubble so one of the parents can catch the error. Number 3, catch the exception and let it bubble up. Maybe let a different exception bubble up so you can handle it and also transfer a different exception to one of the parents. So we now understand the exception journey, starting from the point in your code that throws an exception and the way the exception bubbles down to the parents. We now know the exception journey, as well as we know the possibilities we have with dealing with that exception. We might catch it, or we might let it bubble up to one of the parents to handle. We might catch it and rethrow it. Now that we know all those stuff, it's time to talk about probably the most important aspect of this lesson. What are the best practices for me to deal with exceptions? So the first, and this is just a set of my personal experience, applications that I wrote, application that I managed, a few code that I set for myself for dealing with exceptions. And let me know what you think. Let me know if you have any other things that guide you when you deal with exceptions, any other best practices that you think. Feel free to write anything you want in the comments. This part of the video is my personal opinion about how to deal with exception. And my first mental note when I'm dealing with exceptions, and in general, it's something that when designing an architecture of a system, we tend to do often. We tend to group things together, group them in classes, and group them in libraries, and group them in packages and apps. So the same rule apply with exceptions as well. What I usually do, I try to group exceptions together. And this is something we do often on the software architecture world. So when I think of an app, I think of exceptions that can happen in my app, and I'm thinking about the similarities of the exceptions I have, and I try to group those exceptions together. So similar exception can resurface in multiple places. So for example, I have a user that needs to authenticate, and I have repeating exceptions about users that are not authenticated, or repeating exceptions about users trying to access resources which they are not authorized to access, authorization error. Or I have a repeating exception for dealing with database. So I try to think of my exceptions and ask myself, is this exception something that will occur in many places in my app? And based on that, you basically take your exception and you set your groups of exception. For example, usually I have, in many apps, I have I can say stuff like, all my exceptions, I want them to hold the express request and response object, like, for example, Axios Error is doing. So I might do a parent error class that has additional data about the request and response. And then from that, I'm trying to set additional groups. From that parent error class, I do authorization error, for example, for user to try to access a resource that is not allowed. And I'm thinking all the authorization error might need the user that is currently asking, and might need the path, the resource that is trying to access to. And then I set authorization error and I set another group. And then you create some sort of some sort of pyramid structure or dependency structure of your error groups, and each error group might extend another error group, and a group can have also a subgroup, and so on. So for example, common groups that we talked about, you might think that all your authentication error resemble, and you have them repeating in many places in your app. So you might have authentication error, and you might set that as a group. I have a group in my app for authentication errors. I have a group in my app, a group of exception that relates to authorization errors. I might have a group of exceptions in my app that relates to database query exceptions. And based on that, I'm starting to set groups of my exception. Usually in many applications that I manage, there is usually a library that is called errors, which that library holds the different groups and subgroups of exceptions that occur in many places in my app. When you group exceptions together, it usually involves creating your own custom error classes. So if you have a certain group, for example, if you have a group for authorization error, it's often that you will want to create for that authorization error a custom error class. So group exceptions you combine it with creating your own error classes. So after you classify your exceptions to group, maybe ask yourself, is this group, for example, I have a group of exceptions that I want to throw authorization error, the same error class, the same error instance I want to throw for authorization class are encapsulated in a custom error class called authorization error. I want to throw that instance of this class whenever an authorization error occurs. And then you might ask yourself, if I have authorization error, do I need to add additional data to that exception? It's amazing what that additional data, how much it will help you to solve your errors and bugs. So if you might say, I have a custom authorization error, let me think what kind of additional data, additional function methods that error class needs. For example, authorization error, you might think to add, okay, authorization error, I might add additional data of the user that requested the resource, and I might have additional data of the resource that the user is asking. And then you say, okay, I need additional data, let's create a custom error class. I often use custom error class even if the answer is no. So if you have yes, I want to add additional data, you definitely need a custom error class. I often, every element in my group of error, I create even if it doesn't have additional data, because it might have a common exception code, for example, common data, common functionality, and I can also use instance of if I want to compare that exception in my express error middleware. So even if I don't have additional data like authorization error where I want to add the user and the resources accessing, even if I have, for example, authentication error, which might not have additional data, I would still want to create a custom error class and maybe override the message or override the code to add additional data additional common data, or use instance of authentication error to help me diagnose which type of error I'm now dealing with, which type of group I'm now dealing with. So usually when I group exceptions, it involves creating my own custom errors. Let's see an example in code, what I'm talking about when I'm saying group your exceptions together. So I'll go back to my code, and what I'll do, I'll create a new file for this. Let's make it a TypeScript file, and we'll call it group exceptions. And when I'm talking about grouping exceptions, you need to think about the different groups you have. So you might think different, let's say different groups of exceptions that I have. So you might say, oh, I want all my exceptions to be part of a big group that is called my application error. So every one of my error classes extends that class. So I'm creating a base class of an exception, of an error that represents all the errors in my application. So for example, I can create a class, let's say Academeez error, which is a base class. Now, if you're creating a custom error, the way to do it is to extend the error class. So I extend the error class. Now, if I go to understand, you need to understand the error class. So I would recommend go to the Node.js docs, go here to the errors, and read about the class error. Basically, the constructor gets a message and an additional optional options that contains a cause, the error that caused the newly created error. So we'll focus on the message here. So our constructor gets a message, and I might say that all my errors, for example, I want them to get a status of a number as well. So I will return that status when I'm dealing with that error. So I might say that also all my application error gets the request, which is the express request type. So I'm defining the parent class. So I'm saying this is what I'm referring to groups. First, I set like a big group that holds all my exceptions together. And let's say I create a message. I call the the error constructor with that message. And I'm also creating a public status and public request. And you can set also the name of your error to Academeez error. You can set, for example, a default code. So let's say my default code is maybe it's not. Maybe I can set a field of code. I don't remember if error specifically has a code. No, error has a name, a message, and a stack. So I can set the message, the name and the message, the name to Academeez error. Great. So I created like a parent group of all my exception. Now let's say I want, I see that a lot of users I have authorization mechanisms. So every time a user is trying to access a resource that he cannot access, I want to throw the same type of error. So I might create a class of authorization error that extends my base Academeez error class. Now in here I might set additional data. So for example, my status would be 403, and I get also the request. I pass it to the super. Maybe I get the same message here. So I'm passing the same message. You are not authorized to view this. And maybe I said the name as well. But by the way, just a minor remark: if you're using TypeScript and you're compiling your code to a target that is, for example, ES3. I don't remember the exact. I think ES3 and ES5 as well. You better do object.set prototype of this with new.target.prototype. So basically, there is a bug in when you target old compile in TypeScript that this will refer still to the base error class, and it happens only on native built-in classes like error array map and such. And then you need to do a this set prototype of, and new.target is basically pointing to the instance of your class, the one that you're creating with the new command. So you better do this. But if you're targeting your TypeScript target, so TypeScript target, I'm referring to, if you go to the tsconfig, you have a target here, and you can set it to older version to compile your code to older JavaScript using ES3. And for example, so if I'm putting ES3 here, I better place this object set prototype of. So let's restore it back. Just a remark, most of the time this will be enough. So class authorization error, I might have authorization error, I group all my authorization errors together. Also I might have, for example, authentication error that extends Academeez error, and I might add you're not authenticated. To view this, authentication is usually 401, and you pass the request. So usually when you create your group of exceptions, it means creating your custom error class for each of those groups that you decide, and you decide additional data that your error needs, maybe additional method that your error needs, and then you construct with custom error your different groups of exceptions. So my first tip for best practices with dealing with exception was to group your exceptions. Place certain groups of exceptions, for example, authentication, authorization error, database errors. Decide of certain groups of repeating exceptions, and you can use custom error classes to create those different classes with same code, same status, that group together your exception groups. Now, the second tip I can give you regarding dealing with exception is use common logic for certain or all exceptions. For example, after you decide about your group of exceptions, you might think that if I have an exception that is happening, for example, if I have something that relates to database query exception, I want to perform this kind of additional action with this exception. So if this exception happens, you need to ask yourself, if I have a certain exception happens, when I deal with that exception, is there a common logic that I want when dealing with that group of exception? For example, you might think that for all your exceptions, I want to report those exceptions to my log server when they happen. So you can create also common logic for all your exceptions. Or you might think that whenever I get a certain exception, authorization error, then I want to, for example, write the user and the resources tried to access, write it to the database in case you want to maybe suspend users that try to access resources that they do not have access to. They try to do it for many times. You might want to suspend them. So whenever an exception happens, whenever a group of exception happen, sometimes it involves adding additional logic when dealing with that exception. So this is what I want you to think. Do I have any repeating logic when a certain exception happens? Now, it's not only me that think that you need to add common logic when dealing with exception. You'll find ways in almost every framework I stumbled on. There is a way for common logic for exception, even front-end frameworks. For example, Express has error middleware. Nest has, I think, exception filters. React for the front end has error boundaries. So there are all different ways that the framework is giving you for adding common logic for dealing with exceptions. And we're going to focus on Express, and we're going to talk a bit about error middlewares and demonstrate how you can use Express error middlewares to add common logic to certain exceptions that you want to deal in. Do you want to do the same steps when those exceptions occur? So in Express, we can create common logic for those exceptions using error middlewares. Now, an error middleware is basically you use app use and you place a function where instead of the usual request response next, in the error middleware you have error request response next. So you have 4 arguments in the route handler. So we'll try to demonstrate how you use Express middleware to add common logic to certain exceptions. Now, the API for using for registering an error middleware to your Express application is, like I said, using app.use and placing 4 arguments, where the first argument is the actual exception that you're dealing with. Let's go back to the code to demonstrate how we can use Express and add common logic to certain exceptions based on our exception groups, based common logic in using Express error middlewares. So I have here the custom error classes that we created. Let's export those classes. And after I export those classes, let's do the error middleware logic in a separate file so things will be a bit clearer. So I'm gonna create a new file and I'm gonna name it error middleware, and we'll create it as a TypeScript file. Now let's import the create application function from Express, and let's create a simple Express application with a single route. That's, let's say the route returns the hello world. Now we will use this route to this route will fail with an exception. So we will make this route fail with a certain exception, and then we'll see how our error middleware behaves. Now we can, so let's see for now that our app is running by doing app listen to port 3000, and after that I'm gonna print listening on port 3000. Let's launch our application and see that everything is working so far, and we have hello world is printed. So I'll go to run and debug, and I'm gonna check that my TypeScript compiles just to make sure. No, I need to compile my files. So I have here tsconfig with source map enabled, right? So our source map is enabled, so I can run npx tsc-w to keep on compiling while we do changes. Now I have error middleware has an TypeScript compiler error in line 14. So let's try to fix that error middleware. Oh, forgot to close this. Forgot a bracket here. Great. So now I can launch my my server and see that hello world is printing. So I'll run and debug my code using NodeJS, and let's view that we have in localhost 3000 we have our hello world is printing. Great. So now we are ready to take our Express application and register some error middlewares to deal with common logic with certain exception groups. So let's go back to our code. And let's subscribe an error middleware. I'm going to go back to the previous file, group exceptions, and I'm going to, let's say for all my errors, for all the exception that I have, I want to report to a log server. This is a common logic that I want to be repeated in all exceptions that I have. So I'm going to register app.use. Let's create error middleware that logs to our logging server. And this is like a logic with all the exception, but I still want the exception to propagate to the next error middleware. So it's going to be app.use with error's first argument, request is the second, response, and a next function. We can do import from Express those types. So we have an import type of a request, import type of response, import type of next function. And those are the types here, and the error is of type error. So request is of type request, response is of type response, and next is a next function. Now in here, I'm going to place some code to maybe send a request to our log server, logging all the error fields that I want to log, maybe writing them to a database. So I do certain things here, console log. Let's pretend that we're doing with a console log. We are now reporting the error to our logging server. And after I finish, I can do one of these things. I can either return a response with response send, response JSON, with the regular response sending. I can do also a response status and and then a send. Or, but since it makes more sense, since this doesn't really deal with a specific exception, so it makes more sense in this example. Usually you will probably do something like call next passing the error, passing along to the next error middleware. So you're doing something that is common to all exception, but you're not technically dealing with sending the response to the user. Rather, you are passing the error along after you finish logging your exception. Okay, so this is one error middleware. You can split a lot. You can have many error middlewares, one for each handling with exception. In fact, in my opinion, it's preferred not to have one error middleware to deal with all the use cases. Rather, split them to according to your groups that you decide. So this is an error middleware that logs. It happens for all exceptions. And let's do something specific. Let's create an error middleware for authorization error, where the user tried to access a resource he doesn't have. Maybe we want to write it in the database or do something else, so we know about users trying to access forbidden resources. So we'll create an error middleware that error middleware for authorization error. Let's see. Okay, so this is our error middleware. Again, the first argument is the error, and then I can check if error is instance of authorization error. So if it's an instance of authorization error, let's import the authorization error. Then I'm going to return a status of 4 or 3. I'm going to send you're not authorized to view this, and I'm also gonna maybe console log save user user info and resource to DB to maybe suspend the user. Okay, so this is something that deal with a specific authorization error, and I can do Express also has so basically what I'm doing, if it's an instance of authorization error, I add some logic and return a response. Otherwise, I pass the error along. So let's see our application in action. And so what I'll do here, I'll pretend that I have exception in my route, and what I'll do is I'm going to call the next function with, let's say, new regular error. So in this example, it will only jump to our first error middleware, and then it will skip the second one, and then it will go to the error expressed as a default error handling. And then it will go from here. It doesn't have any more error middleware, so it will go to express default error middleware. So let's try to run our code and place a breakpoint in our middlewares. Why isn't it? Let's add a debugger here, and let's add a debugger here, and let's check what happens. I'll relaunch my code, and I'll go to the route that I set. So I'll go here. It's stopping in. Why is it not showing my? It's stopping in the. It should stop in my debugger. For some reason, it doesn't. Let's try relaunch our code. Go back and. Okay, now it's better. It stops in the first middleware I did. It's console logging. We're reporting to error to a logging server. It's then go to the second error middleware. But the second error middleware, it's not an instance of authorization error, so it's just passing along to the next function, which is the express default error middleware. Now, the express default error middleware simply prints the stack trace. If you're in Node-Env development, if you're Node-Env production, it won't print the stack trace. As well, it returns a status code of 500. Let's see what happens if we now throw an authorization error. So let's stop our server and throw authorization error. We need some kind of we need an authorization error. I don't remember. We don't need a message in authorization error since we're passing a constant message, but we do need to pass the request. So authorization error we do need to pass our request. So you can pass additional data to your custom exceptions, and then you can, for example, add to the exception the resource and add to the exception the user that is trying to access, and then write it to the database. So you're adding specific data to the exception in order to handle the common logic that we placed here. So let's run and debug our code again, and let's see what happens now. I'll go again. It stops in the first logic that is common to all exceptions. Then it goes to the second logic. This time the if is entered because it's an instance of authorization error. So I'm doing something that relates to authorization, like writing the user and the resource is trying to access, and then I'm returning a response. So it's not going to jump to the express default error middleware, and it's just going to return the message, you are not authorized to view this. Okay, so just to conclude this example, what I wanted to show in this example, that almost every framework has some means that you can add common logic to certain exceptions. So first, group your exceptions together, then ask yourself, if a certain exception from my group is happening, do I have a certain logic that is repeating? And if you're in Express, create that logic in an error middleware. The third tip we're going to talk about while dealing with exception is to be specific. When I look at a lot of time when I examine developers' code, I tend to see that it's often the case, maybe it's because of laziness, maybe it's because of lack of understanding of what the exception is. I often see a case where a developer just examines an entire block of code. He sees that this code might fail on exception, and he just automatically wraps that entire code in a big try and catch block without understanding what was the exception, without passing the right exception on. Usually he wraps the entire thing in a big try and catch, and in the catch is missing a lot of information and is just passing along a general exception instead of passing along a specific exception. Remember that when your app fails, one of the things you will go to is your logs, is to check the exception that popped up and caused your server to crash. If you'll see something general, it will be much harder to debug. So try to be specific. Try to not wrap your entire big block that can fail in one big try and catch while losing information when doing so. Try to be specific, to wrap a block of code in different parts, in different try and catch, while understanding the exception and dealing properly with each exception. So to go back to our code, what not to do if you have some kind of route that you are implementing, and let's say this route has 1,000 lines of code in it. That line of code might fail due to authorization error, due to database error, maybe other errors that can maybe reading a file that doesn't exist. So you have different aspects of this 1,000 lines of code that might fail. And the easiest thing to do is just wrap those entire 1,000 lines of code in a big try and catch block. And then in the block, what you'll do is just pass the error to next, for example. So true, if you have a database exception, you'll get here the database exception, and true, you'll pass the database exception along. But are you maybe adding the right information to that database exception? Which database exception? Maybe in these 1,000 lines of code, you can have 10 different database exceptions. So maybe you can wrap each of them in a try and catch of its own to pass the additional data, to pass the right query, to pass the user that performed the query. So try to be specific. It's not always the case that you wrap a block with one big try and catch. In fact, usually when you have a big line of code and you wrap it in one big try and catch, that's usually a bad practice. So try to examine those 1,000 lines of code, try to see what are the failing points, and try to wrap each failing point in its own try and catch while dealing it properly in the catch, while passing the right error, the right exception with the right data to your error middlewares. The next recommendation we have regarding with dealing with exception is logging. You have to log your exception, and it's not simply just log using console log in the same application that you happen to have the exception, because console log are logs that are later harder to inspect. Sometime your exception will crash the process and your console log will get lost. In general, also console log, for example, of objects in the browser will cause memory leaks. So console log is the default, but it's not recommended to use console log. In fact, it is recommended to take the logs elsewhere, maybe to a logging server. And if you don't have a logging server, then your cloud provider, rather than it's AWS or GCP or Azure, have a logging server as a service that you can use without the need to create a logging server yourself. So there is really no excuse, and you should use a logging server to log your exceptions, but also you might log other data as well, log information, log performance. So logging not just exception, but logging other important events that you see throughout your app. Remember that later on, if your app crash, your logs will be the first step you will take to try to solve the crash. You will try to read the logs. So it's important to log and be specific and add as much data as you can while logging. So logging your exception to the console is simply not enough. I can say this, that the app that I manage, I usually enforce a no console log rule, and I usually enforce it using a lint. There is a ESLint rule for not adding console. So there is a rule for no console log. You have to use logger. So usually I use Winston, but there are other logging libraries that you can use. So use some kind of logging library. Just make sure that the logging library can work with your logging server. So if you're working with GCP Cloud Logging, make sure that, for example, Winston have a transport to send the console log to GCP Cloud Logging. So make sure you're working with logging library that supports your logging server. And the major ones, I think you'll have no problem integrating them with your logging server. As I said, I usually forbid the use of console log, so the developers, to log their exceptions or log events, they have to use a certain logger service, and I usually use Winston for that. And the logging service is actually not using console log, only using console log when the node environment is in development. And this way, when the app is running, there is no console messages without the exposing console messages to user, maybe memory leaks, maybe too much logs, not hard to follow the logs later. So usually my rule is prevent the console log and enforce that prevention using a lint rule. As I said, I usually use a logging library. My choice is Winston, but you can write in Google and see the popular logging libraries. Just make sure that that logging library has the transport you need, the strategy you need to work with your cloud, with what you use for your logging server. As I said, do not log in the same application that you're inspecting. It's recommended to use a separate logging service, a logging server, and there is really no excuse because the cloud providers give you that service. So if you search the web, you write GCP and you write cloud logging, you will get to GCP solution to help you log your logging server solution inside GCP. It's also recommended not just to use the logs, in your app itself, but also use in the process manager. So the process manager, that's what will know when your process is crashing, and you have a certain events that you can subscribe to when your process is crashing, and then you can log, hey, my process is crashing due to this error. So it's very important to add that logging also inside the process manager. And let's do a small demo and try to use Winston to log our exceptions. And we'll also try to log our process manager when the process is crashing, log that event as well. So going back to our code, let's learn about how to log properly those exceptions, and in general, how to log. And the way I don't recommend is using console log, because usually the console logs get lost in the way. So what we're going to do is we're going to use a library called Winston. So I'll type in Google Winston npm, and this is a library. It's a very popular library. So it has around 20,000 stars, and it's a logging library where basically after you install Winston, you can create a logger service, and that service you connect to certain transports. That's the strategy that's used to log. Where do you log? Do you log to your cloud server? Do you log to the console, or whatever you prefer? And you can add multiple transports here. So let's try to use Winston. First, we'll start by installing Winston. I'll close the TypeScript compiler watch and do an npm install Winston. Great. So we installed Winston. Now let's go back. Let's start all over the TypeScript compiler watch. So I do tsc-w to start compiling my code. And what I'll do, I'll go and create my logger in a separate file. And usually when I create the logger, I then enforce everyone to stop using console log and use the logger to log instead. So I'll create a file called logger ts. And in here, I'm going to take import from Winston function that is called create logger. And I'm going to use this create logger to export my logger service. And I'm going to create a logger. And that logger will have transports array. And in here, I'm going to add my transports array. Now, usually I connect it to a logging server that I have. In this example, we don't have a logging server, but you'll do it as a homework. I'll have, in Winston, you have certain transports built into the library, as well as you can install transports by npm installing them as well. For example, GCP cloud logging solution also have transport for Winston that you can connect it to Winston to report the logs to GCP cloud logging. So you can also install additional transports that the community built. But Winston has some nice built-in transports, so we can use, for example, transports.console. If you want Winston to report to the console. And usually what I do is I do not use the transports console every time. I do something like this. So I do, if I have, let's comment this. So if my process.env node environment is equal development, then what I do, I place the new transport console. Otherwise, I do not place it, and I'll spread this array. This returns an array which I spread. Okay, so basically this line means that if you have a node environment of development, only then you should add the transport console. And let's add another transport. Add a transport of file. New transport file. I need to specify the file name. You can specify also the level. So only if the level is error or more severe than error. Error is the most severe, but you can say, okay, I'll give the level as a warning. Let's keep it as error. Then you transport to a file called error log. Great, so this is a really simple logger. We'll export this. We'll go back to our error middleware. We're gonna import this logger that we just created. And instead of my console logs, I will now use Winston. So for example, in my root, triggering an authorization error, which goes to this. Instead of console log here, I am going to use the logger.error and pass the error.message. Why is the logger not working? Cannot find name logger. Oh, sorry. Forgot to finish the import. Great. So now I'm logging the error and printing the message. So it should log in the console because I'm in node environment development, and it also should log the error to a file to create a new file called error log and log the error there. So let's try to run our code. Now, if I try to run the code, there is a known issue in VS Code that Winston does not print to the debug console. So we're going to launch our code in a different way. I'm just gonna open the terminal and do a node error middleware.js. So I'm going to launch the code like this, and let's go back to the browser and let's go to the root where an error is triggered, and let's see what the result is. So I do, did I compile my code? Did my code compile? 0 errors, that's good. And I'm sending an authorization error, and I'm logging the error message. And for some reason it did not log, or sorry, I'm in the wrong console. Let's see again. No, it did not log. Let's try node error middleware JS. Let's launch the server again. Okay, for some reason it didn't work. Why are we not exporting the create logger? We're exporting the create logger. Node environment. Let's see if the file is created. So we see, do we have an error log file? Okay, so it did log to the error file. It didn't log to the console. Let's see, probably because of my if here, process node environment is equal development. So let's try to run our code with node environment development. Let's try now, and let's launch the code. Okay, so we have the error log is logging to the console now. So I just launched my my app using node environment development. Okay, so just to summarize this this small exercise, it's important to log the errors. I usually use some kind of logging library, like we saw here. I used Winston. This way I can connect my logging library to several transports, and then I can have the log automatically transfer the errors exception info to my cloud logging server. And we saw here how we can do this using Winston. Now let's see another thing. Let's try to run our app using a process manager, and then try to log the errors if our process is crashing using processor manager event, using PM2. Great, so let's run our application using a process manager, and specifically we will use PM2. So as we mentioned a few times, if you go to Express Docs and if you go to Advanced Topics, you have a topic about process managers. And in the docs, Express recommends not to run your application using simply Node and your application. You should run your application with a process manager. Specifically, one of the process managers they recommend is PM2, and let's show what it is. Let's run our app using PM2. Obviously, you can choose a different library. Same as Winston. If you're choosing a different logger library, that's fine as well. Make sure to write in the comments which library you're using and why. Just make sure that the library you choose has the specific things that you need. So we're going to launch our app using PM2. So let's click the PM2 here, and let's open their docs, and we're going to install PM2. Now you can install PM2 globally, and then you will have a CLI command which you can use that command to launch your app, or you can install PM2 locally, and you'll still have the same CLI command, only you will be able to use it locally in your project. We're going to install PM2 locally, so let's go back to our project and do npm install PM2. Great, and we are going to launch our, basically you can now use the CLI command, so I can do npx pm2, and let's do -- help to see the different commands that I have. So basically you can launch with this CLI command. We can launch our app, but for more advanced usage, like if you want to monitor your process and know when an exception happened to your process, you should probably use a script to launch PM2. So let's do it in a more advanced way by creating a PM2 launch script. So I'll go to the project, and I think in most of the advanced projects, you will probably have to eventually do some sort of PM2 advanced configuration and script. So I'll create here a PM2 file. And in here, what we're going to create, we are going to create a PM2 launch script, which launches our application and also monitors if our application has exceptions. Great. Now let's have a few. Let's talk about PM2. Few advantages you have when using a process manager. So why should I use process manager to launch my app? I think the most important feature a process manager has. So let's talk about PM process manager advantages. And the first one will be restart the application if it crashes. So if your application process is terminated, for example, due to exception, PM2 can automatically restart your application if your application is crashing. So that's one aspect. As we said, there will be cases where you do not catch your exceptions. Your process might crash. You might have severe bugs that make your process crash. It's not the end of the world. I would say it's in a big application, it's almost inevitable to happen at some times. So it is important that you just expect it to happen, monitor that event, log that event, and prepare yourself when this issue rises. So it will probably happen. I think the second advantage is you have in PM2, you can run not a single process, you can run your app in multiple processes. So you can run your app in cluster mode, run your app in cluster mode. And in cluster mode, your process, PM2 will run your app in a few processes. You can do it when your application is stateless. So for example, if you need to share a session, it might not be suited for extreme cases like that. But if your application is stateless, you can actually duplicate your application in a few processes. PM2 can also automatically open a few processes based on the cores you have in your computer. So you can run your app in cluster mode. And also PM2 will load balance between the process, so it will also monitor memory usage, CPU usage of the process, and load balances based on the process that can handle the request best. There is a few. I think those are the major ones. You have also a web GUI where you can see your process running and you can see the logs of your process and how much memory and CPU. So there is a good monitoring in PM2. Check the docs for additional features that they have, and let me know if you're using a different process manager to launch your Node application. It works also good with Docker. They have in their docs. Let's check their docs for a second. They have their docs, I think here, official. So it works good also with Docker integration. It can log to file, and you have a GUI to monitor your logs. And it can help you with deployment, but personally, I'm not using that as my deployment solution. Various other features, you should check their logs and let me know in the comments if you're using a different process manager other than PM2. Okay, let's launch our app using PM2. Now, we're going to launch our app without the PM2 CLI command. Rather, we are going to use feed PM2 with a launch script, and this will launch PM2 with a script telling PM2 what to run. So to do this, we're going to advance. We're going to PM2 JavaScript API, and we're going to follow the example they're giving us here. So we are going to import PM2. Let's import PM2 from PM2. We're connecting to PM2. We'll copy this code. We'll start our script. And if everything runs okay, we are going to basically list the process that's running. We're not going to use this. Let's copy this entire code and delete what we don't want. Sorry, let's copy it properly. So for now, what we're going to do is simply run a app with PM2, and that's about it. So we're connecting to PM2. If there is an error connecting to PM2, we're going to process exit. If there is not an error, we're going to start our app, which is called error middleware.js. So error middleware.js. And you can name it, so afterwards you can refer to what PM2 is launching. And if it launches successfully, and after it's launching the app, it's going to run this function. If you have an error launching the app, you'll have an error first callback here with an error, which we can console log and PM2 disconnect. We can delete this list here. And that's about it. We're simply going to run a app. Let's change the name here to error middleware. Now let's go back to our app, Error middleware, and we'll simply send an hello world. So we have one route get for the root, and we are currently sending an error. So we're going to just response.send hello PM2. Great. So let's see if we manage to run PM2 and run our app with PM2. So let's go back to the PM2 script. Let's see, open the terminal. In the background, I have TypeScript compiling my script, and I have no errors. So I should be able to launch my app with a run and debug. I can place a breakpoint here just to see that there is no error. So let's run and debug. It stopped here. There is no error, which is good. Okay, so running our app. Let's go back to the browser, and let's see that we have hello PM2. Great. So it did manage to run, PM2 did manage to run our app. Now let's see how we can use PM2 to actually monitor the process and actually know when my process is crashing, and use PM2 to log. Obviously, you can also not use PM2 log. You can also go in your Node Express application, and you can also implement, as we saw, we have the process on, we have the event of I don't know what was it called, unhandled uncaught exception. So you have this exception, which basically you can also use to log your errors. So in here you have you're getting here the error, and you can use the logger that we created to log an error and log the appropriate error, and then you have a callback. After the log is finished, you can exit the process. So do not remember that when you handle this event, it prevents Node from crashing the process. You do want to crash the process if you have an uncaught exception. So what I would do is log the error, something happened, and in here you can pass, in Winston, you can pass a callback after the log is finished, and then you can do a process.exit with a certain exit code based on the error. So this is another thing you can do from inside the app. You can monitor an uncaught exception using the uncaught exception event and then log your error. You can also do it with PM2. So PM2 has a link to the process that they're running, and when PM2 notices that your process that is running has an exception, it can use the logger to log the exception as well. So in case you can implement this if you want to log the exception that you're not catching from the actual app, or you can use PM2. So PM2 can be aware when the process it is running is crashing, and then it can log the exception. So yeah, I think it's launch bus. Let's copy this code here. Okay, so basically it's creating bus messaging from PM2 to the process it's running, and I think it's bus on process exception. Your bus will get a message on process exception, and here you get the packet. Let's do it as any with information about the message, including the exception that happened, and let's log this packet data, I think. So basically you are trying to intercept an exception message from your process, and then you can use the same logger service that we created earlier to log that exception. Just to run things, we'll go to Error middleware TS, and let's do after set timeout after 2 seconds. Let's do after 2 seconds, let's crash my app with an uncaught exceptions, just to see that indeed PM2 can be aware when the process they're running is crashing and can log the error. So let's do a set timeout that will run after 2 seconds with throwing a new error. This will crash the process. Great. So let's relaunch PM2. So I'll go back to PM2. I'm going to do a list if I have something running on port 3000, because sometimes when you close with the debugger, like I did now, it doesn't fully close the process that PM2 ran. And I see that indeed I have something running on port 3000. So I'll just close this. Great. So let's try to run PM2. Let's see if this log is we're getting this log with the exception that our app is throwing. So let's run and debug this, and let's see in the debug console. I see that I do get an exception. And as you see, this exception keep on occurring. This is because PM2 is going to always, when your process is crashing, PM2 will going to restart the process and launch it again. So this log does not happen once. It happens every time when PM2 restarts your process. After 2 seconds, your process is crashing. PM2 is logging and restarting your app. Let's stop this and examine the logs that we get. So I see here that I get something happened with the exception in PM2, and then you can use the logger service to log that exception. So we are actually monitoring our process from PM2 as well. So the most important thing that I think we talked about in this example is logging your exception. So you should create a logging service. That logging service should communicate with the logger server. If the logger server, if you're low on resources and time, you can use a cloud service for logging your errors. You can use a library that will log the error to your log service. In this example, we used Winston. So you can use Winston to log your exception. It will go to your logger service. In general, I would recommend also to create a lint rule to prevent console log. Also, I would prevent also monitoring your process in the case of uncaught exception. So you're running your process using a PM2. You can monitor the process you're running, that PM2 is running either with PM2 or in the process, and you need to log the event that your process crashed. You need to add a log to log this to your logging service as well. So log your errors, run things with PM2, be ready when you have some uncaught exception that will crash your process. So we have reached the end of the lesson. Hope this lesson gave you some insights regarding how to deal with exceptions, a few ideas, best practices. So just to summarize this lesson, remember your node process will crash if you have uncaught exception. So the first thing you should be aware of that, yes, you will have uncaught exception. You should run your node process, your node application, your server, you should run with a certain process manager. In this lesson, we demonstrated running our app using PM2. Let me know if you prefer other libraries, other process manager other than PM2. But you saw here that PM2, what it does when your process crashes, PM2 will restart your process, along with additional features that other nice features that PM2 has. So run your code using a process manager. We saw that Express does not really help you with asynchronous errors. So Express does not help you if you have uncaught promise rejection, if you have uncaught event emitter, if you have an error first callback, which you do not deal with the error. Express will not help you deal with asynchronous errors. You can, however, install the Academeez Error middleware, which will basically give your Express support for asynchronous errors. So when you install Academeez Error middleware will help you catch promise rejection, event emitter, error first callback, and will help you transfer you to Express Error middlewares. So in case you do want Express support for asynchronous errors, feel free to try our middleware. Feel free also to comment star in our GitHub repo. We place a link to the Academeez Error middlewares in the video descriptions. So please check it out and star if you like. Also, remember the best practices we talked about. Try to group your exceptions together. You can group them. Often when you group your exception, you will want to create custom error classes that we saw here. If you're grouping your exception together, a lot of your exception will have a similar logic. So you can use Express Error middleware to create common logic for those group of exceptions. Remember to log your exceptions. Use some kind of logging server. There is no excuse. You have this as a service from your cloud provider, so there is no excuse to not use a logging server, and use some kind of library to help you log your errors to that logging server. In this lesson, we demonstrated things using Winston. Write me down in the comments if you prefer other libraries and why do you prefer those libraries. So we saw that we can log our exception using a log server using Winston. Feel free to also add a lint rule to prevent developers from using console log and only using your logger server, your Winston service in this example, or your logger service if you're using other libraries. That's it. Let me know in the comments what you think, how you deal with exception. Hope you learned from this lesson, have some ideas how to deal with exception better. And that's it. Thank you for listening.